Hello guys, today I want to talk about my 6th step of machine learning journey at CS internship. First of all, I will focus on what machine learning concept is and why is it so popular around the world among many people. After that, I will talk about the different types of machine learning, subsets, and finally, I will focus on implementing some Python codes through machine learning algorithms. I won't implement all of the machine learning algorithms in this switch. It's not logical actually. I will categorize them, the supervised and unsupervised one in this switch, and the reinforcement learning and one of the actually unsupervised learning algorithms on my other switch, which will be switch number 7. So follow me. I would like you to imagine that we want to make a Caesar salad. What do? We will chop the lettuce, we will slice some bread, we'll slice some cheese, and we will pour the Parmesan cheese. The thing is that the question is, why don't we use these all of the stuff, all of the material, the whole of them? I mean, why can't we just put the whole lettuce on the bowl and put the whole grilled chicken on the bowl? The thing is that this is exactly what we do in machine learning. We will actually we will have some operations on our raw data, which is called pre-processing, in order to make the most use of our data. This is exactly what we do through machine learning. We will give the ability to our computer to learn from the data by making it as an array of numbers in order to store it in the most effective way. And finally, we will have our machine learning model in order to learn from the patterns among the data and make the best prediction about the future events. So this is what we do through machine learning. Now, as you know, we have three types of machine learning, which are supervised learning, unsupervised learning, and reinforcement learning. I want to show, I want to manual on one of supervised learning algorithms, which is a classification. I will explain it through an implementation by Python. So let me have my code. Okay. To understand what pandas is and why do we use it here, you can I can refer to my last tweet number 5 that you can watch. There I have explained the three essential libraries of pandas, numpy, and matplotlib there, and you can watch later what pandas do. Okay, I have imported pandas and TensorFlow, the main library of machine learning for my implementation. The dataset that I wanted to focus on is the dataset about buying various houses. Our house has two main features of area and number of bathrooms. Look, what will be our inputs in here? This is actually clear, the area and the bathroom. But the thing is that I want to I want not to use, I don't want to use some of the features through my dataset, which are, for example, index, price, and square price. As you see, I have dropped them. I don't want to use them. So, now, what will be our output? The output will be whether I want to buy this house or not. If I liked one house, I will have the number 1, and if not, otherwise I will have number 0, that I don't want to buy this house. Okay, so as you see, we have the inputs and outputs in here. For the next step, I just define them as input X and input Y, and just printed the inputs and outputs for seeing better. Now, the point is that how can my model have the best prediction? Okay, it's clear. We must define a variable which is called the raining rate, and we should define the number of the training of our model 2, which would be the training epochs that I have defined and set the value of 2000 for each of them. Okay, now we will have the samples that we want through our training process. So what we do to our model is that, remember, for the perceptron formula, not only we would use the input, but we would gather two more structure, which were the updated weights and the bias unit. We would multiply the input and actually the weights, and after that we would add them with the bias unit. This is exactly what we do. I had actually defined the weights and the bias, and also a matrix for our dataset to actually have a better perspective of that. But as you know, we will have some actually lost materials through our learning process, that you can watch the formula of cost function in on the internet, in Python machine learning book, etc. And for the optimizer, I have used the gradient descent, that for actually optimizing the learning rate to be its best version. So after that, I just wanted to have an initial perspective of it, and we started defining a for loop in order to have actually a repetition number of training epochs. So as you see, we have chosen the input x and input y actually to work with through our dataset, and after that, when it's finished, we will actually print optimization finished so that we can watch the outputs. As you can see, for the output part, we have the training step, which actually is going by 50, 50, 0, 50, 100, 150, adding 50 steps. And we will have the cost, and as you can see, the number of costs in here, the pattern how the cost function works is so important to us, and we must pay attention to it, that whether it increases or decreases. So actually, this is, I don't want to say that whether my classification algorithm works well or not. I just wanted to show you a small pseudocode about classification. I will talk about the advanced parts in my next speech. Okay, that's it. Now I would like to focus on another actually algorithm used in I don't know, the supervised learning task. So as you know, we have got some actually numbers which aren't discrete, they are continuous. And for example, we have a structure that one part depends on another part. Imagine that we have a data set that we've got for example 50 numbers of employees, and we want to actually we have the number of the years they have worked through the company. Now we want to calculate whose salary is more than the other ones. This is exactly what we do through linear regression algorithm of machine learning. So I have imported the libraries that I want to focus on, and I have used the salary data CSV file for my dataset. I have actually brought a better perspective of my data set in here. As you can see, we have some parts like mean and max, and the number of I don't know, the workers, the employees in the company, etc. Okay, let's have a distribution of the actually salary and number of the ages that actually we have for each of the I don't know, people who have worked for that company. Here you can see this distribution. This is not the thing that I wanted. This is not the linear regression algorithm. I just wanted you to see the distribution through the salary of each employer. Okay. Now, how about the relationship between the salary and the number of experience each employee has? So as you can see, I have gathered actually two-dimensional diagram with X label and Y label. As you know, we are talking about linear regression in supervised learning. We've got some label to actually define. Now, so I have chosen some plots, as you can see, and the actually X part will be the years of the experience, and the Y or the output one will be the salary that each employee has. Okay. I have defined the inputs and outputs already. Now it's time to actually categorize the data set into two parts of training and testing. It depends on you. You can actually work with, I don't know, you can say that 80% of my data set will be on the training part and 20% will be on actually the test part. It doesn't matter. Okay, now sorry for the thing that happened. I don't know why. Okay, now it's time to train and define our regression model. So as you can see, I have defined it here, and I have given the actual variables x test and x train in each of them. Be careful that we must behave with x train, x test in one way and y train and y test in another way. Okay, so as you see, I have started the prediction process and have actually implemented a direction for you in order to see how our model is working. Now the question is that what is this red line? As you can see, we can define it as a fitted line. That the thing is that we must actually examine how far the distance between each of the points through our dataset is from this fitted line. We want to understand this through the linear regression. So the fitted line is actually the most important part of our actually matplotlib diagram. So in here I have already a prediction on the train test before, and now it's time for the prediction on the test set. As you can see, we will have this plot for the train part and this part for the test part. So the thing is that in test part, the distance between the points and the fitted line are lower than the training part. So the benefit, actually we are benefiting from this model, and it has a good output. So we are working well through this algorithm. Okay, this was about the supervised learning. Look, I'm not gonna manual on reinforcement learning a lot, and we've got another algorithm for the unsupervised learning, which is dimensionality reduction. Because of having various algorithms on dimensionality reduction, it has a lot of subsets. I prefer to talk about it in my Twitch number 7, which will be held in a few weeks later. So now I'm gonna focus on another actually algorithm, which is for unsupervised learning. Let me bring it. For the unsupervised learning, we've got an algorithm called clustering, and another one that I talked about 1 minute ago, which was dimensionality reduction. Okay, I'm gonna focus on the clustering part. Okay, as you see, what we mean by clustering is that imagine we've got some pencils, and erasers. We want to categorize them in 3 groups. What do we do? Actually, it's not logical to have one eraser, one pen, and one pencil in each group. The thing is that I want each category to have the most similar actually stuff in it. So I want to have erasers in group 1 and pens in group 2 and pencils in group 3. I have already imported the desired libraries. Here we are going to focus on a grid, so I have just defined it, and we will have some features and samples that, for example, I have defined 500 for them, and also the number of groups that I want to focus on. Okay. I have because of having 3 groups, I have defined a K to 3, and here we have a formula that we want to focus that each group, how can we understand that each point refers to each actually category. This is the formula that I have used. You can find it through the internet or whatever that you want. So this part is for defining the clusters that we want to focus on, and also for understanding that which point should go to which group. I have also defined a marker, which is the star symbol and the color of it is red, so that we will understand that which data point should go to which group. Okay, here I have actually put a function in order to actually calculate the distance between each point, so that we will understand that each data goes to each group. So in here I have actually defined a for loop, so that we will actually do the train and test actually uh, things better and better. And after that, remember we talked about updating each time that we will have the output. So in here I have just defined another function and in a for loop, so that I can go through by each repetition that I would like to have from each cluster. And here again we will just have some, it's just the implementation part I don't want to focus on. We will have another loop for our clusters in order to I don't know, have their desired color, their similarity, etc. And after that, as you can see, each point refers to each cluster that we wanted to focus on. So for example, the yellow one would be the pencil, the purple one would be the pen, and finally the blue one would be our I don't know, the eraser. So as you can see, each point is in its own category. This is a really small and easy implementation of clustering. I really wanted to focus on the mm, dimensionality reduction too, but it really can be done in 20 minutes. So I will focus on the reinforcement learning, I don't know, implementation, and the actually uh, dimensionality reduction on my next switch. Okay, so we have talked about them. Thank you so much. My Twitch is finished now. I hope that it was enjoyable to you. If you liked my presentation, please follow me on LinkedIn. We will have lots of information in here. I will post various stuff in there. And you can also subscribe to my YouTube channel at Dorrin Sam, or CS internship channel, which I work for no difference. So thank you guys. See you on Twitch number 7.